Hello and welcome to the Physics Basket. The topic that we are going to cover are Class 9 Topic 1 Foundation, and the topics are Understanding Inertia, Newton's First Law of Motion, Net Force, and Summary. So let's get started. So let's first understand what is inertia. So inertia is basically a tendency of an object to resist the change in its state. So this brings in a question, what are the different states of an object? Maybe with respect to physics. Basically, we can say there are two states. One is state of rest. The object is at a state of rest, like this simple example wherein a ball is on top of a table and it is in a state of rest. It's not moving. And the other state is the state of motion, wherein a ball is moving on a smooth surface continuously, unless it is objected by an external force. So these two are the different states, because of which these two objects have acquired some property called inertia. The object which is at state of rest has acquired a property called inertia of rest, whereas the object which is under motion has acquired a property called inertia of motion. Let us understand it further. So inertia of rest. As we see, this ball is on top of this table and it has acquired a property called inertia of rest, because it tend to be at this position unless it is objected by an external force. And similarly, we are seeing a ball which is moving on a smooth surface, and because of its movement, it has acquired a property called inertia of motion. And it tends to be in this position unless it is objected by an external force. Which brings in basically the first Newton's law of motion, which states that an object continues to be in its state of rest or of uniform motion unless it is compelled by an external force to change its state. So since there is no external force that we see on these two bodies, they continue to be in their state of rest and motion respectively. So the question that we can ask ourselves is, will any kind of a force change the state of an object? The simple answer can be no, because we can come across objects wherein there are multiple forces but they don't change their state. So basically it need to be an unbalanced force to change the state of an object. If there are multiple forces acting on a system, then the net force or the resultant force of on the system basically should be an unbalanced force. Let us try to understand this with an example. Let we see this object is basically resting on top of a surface, and we see there are forces acting on this body, its own weight, which is basically due to the gravitational force of attraction of earth downwards. So the weight is acting downward, and since it is on top of the surface also exerts a force in the opposite direction, which is nothing but this normal force, which is in the opposite direction. So this normal force and the weight of the body acting downward are basically balancing each other, and irrespective of multiple forces acting on this body, the body is still at rest. So basically the resultant force on the system is zero, since the normal force is equal to weight of the body, or n minus w equal to 0. So there's a very reason the body doesn't move. So let us take some further example. A familiar example is this pulley, which is a frictionless and a massless pulley. The force is being applied on one direction and the mass is hanging on the other side. The weight is acting downward, as we can see, and the force is applied on the other side. Since it's frictionless and massless pulley, the same force will be exerted on the other side of the string. In this free body diagram, we need to basically understand in which condition the body will be stable, or the body will move downward, or the body will move upward. So basically, if we check the net force, if we try to calculate the net force, then that will be F minus mg in the upward direction. And it depends if F is greater than mg, or F is equal to mg, or F is less than mg. Based on that, the body movement will be decided. Let us understand it further. If the body is in equilibrium, irrespective of the force being applied, which simply means that F minus mg is equal to 0, because the total unbalanced force is 0, means the F equal to mg, right? And then if the body starts moving in the upward direction because of the applied force, so it goes in the upward direction, which means that the force is greater than mg, or F minus mg is greater than 0. In case, irrespective of this force being applied, the body still moves in the downward direction, which means that F is less than W, or mg. F is less than mg, right? So this is the condition. So what we have learned so far: inertia of motion. Basically, some examples we can take. A person in a bus leans forward and the bus stops suddenly. Simply means that the person has already acquired, being in the bus which is already moving, it has acquired a property called inertia of motion, and because of which when the bus stops suddenly, the person will lean forward. Same is the reason when somebody is jumping off, of course, something which we don't intend to do, but just for an example, from a train, then he might fall forward. That is because he has acquired a property called inertia of motion. Inertia of rest, a very similar example. You are in a static bus and then the bus starts moving, then you will lean backward. That is because you have already acquired a property called inertia of rest because you are in a static bus and the bus starts moving and the body is not aware of the sudden movement and it starts to lean backward. Same is the case for a pile of coins in a carom. When you strike it with a striker, then only the bottom one moves and rest of them stay in the same place. That is because of the inertia of rest. And then to summarize, the change in state of an object happens only when there is an unbalanced force on the system, which is what we have learned also from the first law of motion. An object continues to be in a state of rest or of uniform motion unless it is applied by an external unbalanced force to change that state. So this brings us to the end of this topic, and the upcoming topics are Class 9 Foundation Topic 2, which includes Introduction to Momentum, Newton's second law of motion, Law of conservation of momentum, Newton's third law. Till then, stay tuned and thank you for being here. Subscribe for further updates. Thank you.